All right, so you recognize that solving this formula for A, and this is what we had just talked about, if you divide both sides by a probability of A, that's where this comes from. Okay? So as long as the probability of A is not 0, in other words, it has to be able to happen, then you're in good shape. All right, let's look at this and let's do it. Let's just kind of go through this problem and see what we end up with. Courtney draws a card from a standard deck. As an American teenager, how many cards are in a standard deck? 52, so you know that. Find the probability that she drew a king given that she drew a face card. Now again, little timeout, American teenagers. What are our face cards? King, queen, and jack. Ace doesn't count as a face card, right? All right. And how many of those are in the deck? There's 4 suits, right? So isn't there 12 of those? Okay. So there's 12 of these in the entire deck. All right. What I want to do in order to use this formula, of course, I need to know the probability of A and B. I also need to know the probability of A, and then I'll divide them. So I just did these two as kind of mini steps, step 1, step 2, and then here's the actual formula. So let's talk about the probability of, actually A is easier. Let's talk about the probability of A. Well, actually, you know what? I don't know which one's A and B. So let's change and let's talk about A's and B's. This says the probability of B given that A has already occurred. So I want the probability that I have a king given that I drew a face card. So which one's going to be my B and which one's going to be my A?
B is the king.
All right, A is the face card and B is the king. That's correct. So this really says the probability of me getting a face card. So what is the probability of me getting a face card from this deck?
12 out of 52.
Okay, there's 12 face cards out of 52. 12 out of 52. And of course you're welcome to reduce that. What about A and B? That's not really A's and B's. It's really the probability of a face card intersecting with a king. How many times does that happen? 4 times, right? How many face cards are kings? Face cards are kings. There's 4 kings. So 4 face cards are kings. Yes, sir. Like you guys just said, there's 4 kings that are face cards. Of course, all kings are face cards. In the deck of 52. So here is my intersection, 4 out of 52. Here is my P of A, 12 out of 52. Well, now I just put them together and do the math, right? So I've got 4 out of 52 divided by 12 out of 52. And you have to remember your fractions now. How do you divide with fractions? That's right. You change it to multiply by the reciprocal. And this is where I told you it really didn't matter, because look what's going to happen with your 52s. They're going to cancel out, aren't they? So when those cancel out, you can tell the answer is 4 out of 12, which of course reduces to 1/3 or 33.3%, right? So, like I said, I'm going to leave the answer 4 out of 12 since we already know the answer is 4 out of 12. Let's see if we can come up with that reasoning a different way. Forget about these two. I mean, we can still do that, but let's forget about it. Let's just focus in on what this really means. It says, find the probability of, now we have B's and A's. Remember, that was really the probability of a king given that it's a face card, right? What is the sample space in king given that it's a face card? Am I really talking about the whole deck anymore? No. What am I talking about? I'm just talking about the face cards. Right? I have 4 kings that are possible out of the 12 face cards. So that's 4 out of 12. Wasn't that a lot faster? But do you notice what happened? Is we still ended up with the same numbers, right? When I did it the long way, that whole denominator right here, it ended up canceling out, didn't it? Okay? And that will happen every time. So if you already know the sample space, or the sample space is small enough to figure out, sometimes this formula is tedious and too long. Okay? And it's easier just to common sense your way through it. So in either case, you get the same answer. Okay? Just kind of remembering what we knew from last year. What does this number 342 mean? It means... Exactly. There are 342 boys that said yes, they're going to college. How many girls said yes? 376 girls said yes, they're going to college. How many boys said no? 151 boys said no, they're not going to college. And of course, 138 girls said no, they're not going to college. I have a question for you, though, that's not on this table. See if you can help me. How many kids said yes, they're going to college?
718.
Yeah, you just want to add this up to the side, right? So there's 718 kids that said yes, they're going to college. How many are not going?
289.
All right, I'll trust your math there. So that's pretty clear. Even though it was not written in the table, you know you can always add those up, right? By the way, if there's 718 going and 289 not going, how many are there total? Should be 1,007, right? All right, I know that 342 boys are going to college and 151 boys are not going to college, but how many boys are there? Okay. 493, and of course you can add up the girls as well. And I hope that 493 and 514 equals 1007, does it? All right. So double check that for me, please. But remember from frequency charts, even though it's not written, you know that the totals are always on the ends, and you can always add them up. Okay? And that's something you'd be expected to do. And that's a good way of just doing some arithmetic to check that these columns and the rows and the columns equal up. Okay? Now back to the original question. I want to do it with the formula first, and then I want to do it more common sensey and see, if we end up with the same thing. So I'm talking about the probability of a student attending college after high school if I already know it's a girl. So that would be, yes, they're going to college if I know it's a girl. That's what my formula would look like. So let's think about the previous formula. What would go on top? It'd be the probability of girl and she said yes
376
over the probability that it was a girl. Right? So let's go through each of those. Okay? The probability that it was a girl and she said yes, she's going to college. Well, how many girls said yes, they were going to college? 376. But that's 376 out of how many? No, that's 376 out of 1,007. All right? Because this is the probability of the girl. It has to be a girl and she's going to college. Okay?
And then it's all girl out of all of them.
And then second one says the probability that she's just a girl. Well, how many girls are there? 514 girls out of 1,007. So once again, now you just use your fraction rules. 376 over 1007 times 1007 over 514. The 1007s will cancel. And you're left with 376 over 514, which, go ahead and get that as a decimal. It's about 73%. Okay. Sometimes the formula does get a little tedious trying to keep track of it and knowing what the denominator is. Let's do it again. Notice this is the same problem right here. Let's do it again, but this time I'm not going to use the formula. I'm just going to more common sense my way through it and really talk about what this syntax is trying to tell me. Now this says, once again out loud, it says the probability that I got a yes, a person that yes, they're going to college, given that I know it's a girl. Well, because I know it's a girl, what's the sample space? There's only 514 girls. I do not care about the guys right now. So I don't care about all 1,007 students. I only care about the 514 girls. So out of the 514 girls, how many of them are going to college? 376. And you can see, look, I end up with the same numbers, right? But this way seems a little more common-sensy, at least to me. But you have to understand that in this situation, you have changed the sample space from the original problem. And of course, the answer is the same. It's about 73%. It's going to be your choice on situations which way to go with that. So this reads the probability that I have chosen a boy, given that I know they are not going to college. So which kids are not going to college? How many? 289 are not going to college. Okay? So I know that there's 289 not going to college out of how many boys? Or excuse me, how many of those are boys is what I should have said. 151 of those are boys not going to college, right? And then of course you just reduce. These two over here aren't necessarily conditional. Let's reread. What is this trying to tell us? The probability that is a boy and they said yes. So this is a boy who said yes, they're going to college. How many boys said yes, they're going to college? 342 boys said yes, they're going to college. Out of how many? Oh no, out of everybody. Okay? Because it's not conditional. They're not talking about, I don't know that it has not been given to me that I'm only talking about boys. Now this one says, given that it is a girl. This one says, given that it's a no. This one doesn't say given that anything. So there is no condition on this. Therefore, the sample space is the entire sample space, which is 1007. And then you can just divide, what is it? 34%? All right. Same thing on this next one. Let's try to read. What does bug stand for? B-U-G, what is it? Okay, B union G, which means boys or girls. We want to use the word or there. But how many boys or girls together intersect with the yes? So how many boys or girls together are there? 7 that intersect with the yes. 718 boys or girls intersect with the yes, right? So there's 718 that intersect out of how many? Okay, it's 1,007 because it is the entire sample space. I didn't put in conditions on this. All right. 71? All right, 71%. All right, if you guys will take a minute to do these problems, I'll put the answers up. Okay, so when I read this right here, it says the probability that the student is on varsity, given that I know that they're a senior. So am I talking about the entire school now? No, I'm only talking about seniors. So my sample space has changed. So my denominator is no longer 1180. My denominator is now going to be just the seniors, which is 308. So there are how many varsity? out of the senior class, which is 308, how many of them are varsity? 51. This is telling, where am I? This is telling me the varsity people, given that I'm only talking about seniors. So right now, I can scratch all of this out. I am only looking at this box. Oops, go away. I'm only looking at this box right here to do this problem. Okay? Because the sample space changes.